Good afternoon, good afternoon, good afternoon. My name is Dr. Kelvin Mackey of STEM Nola, and once again, I'm here to bring you STEM Illinois. Years ago, I met Chancellor Robert Jones of the University of Illinois. He came down to New Orleans to see the great work that we were doing in the community. And at that moment, he said, I really want this for the university and for the community in Urbana-Champaign. And he said, Mackey, I want you to work with my people and let's make this happen. So for the last 2 years, my team here in New Orleans have been meeting with people from the University of Illinois to start up, initiate the model that was created here to engage young people in science, technology, engineering, and mathematics all across the state of Illinois. The pandemic hit, COVID, we're still dealing with it. Remember, mask up, get your vaccine. There's only 3 ways to defeat the virus, and that's to mitigate, or separate. So you got to stay a certain distance away. If we got medication, we got to use the medication. We have to mitigate it through vaccination. So with COVID, we put everything on a back burner. Then eventually we said, hey, STEM Nola got up online and started doing STEM at home virtually. We're now engaging kids in 47 states and 5 countries. And the people at Illinois say, you know what, let's do that. And let's lead up to the virtual STEM Saturdays and then the in-person STEM Saturdays when everything come back after COVID. So this is our 3rd or 4th STEM at home, STEM Illinois at home, and I want to welcome everyone. You know, in the 21st century, our children only going to have 1 or 3 options. Either they're going to take something, break something, and or make something. And if we don't give them the skills and education to make something, like make a living, make a life, make a difference, that's only going to leave them with the 2 options that we see on the news every night. And science, technology, engineering, and mathematics is the area of disciplines of subjects that kids can study and become STEM literate, but also receive the skills that they need for the 21st century, like critical thinking, like communication, like collaboration, and like creativity. When we do these hands-on activities, we say hands-on mean minds-on. And I started doing this 8 years ago in the garage with my 2 sons, the 1st grader and the 3rd grader. And 8 years later, I just walked my son into an engineering program at Howard University. And the most beautiful thing about doing the hands-on projects with my son and with other kids, we are now meeting kids who have a basic understanding of phenomena, a basic understanding of how things work, such that when they do get in school, the STEM is demystified. They're not afraid of the equations, they're not afraid of the big words, they're not afraid of the theory, because they can look around them and see that STEM is all around them and they know how it works. In the 21st century, we're either training ourselves from the neck up or we're training ourselves from the neck down. If we're training ourselves from the neck down to do physical work, our competition, young people, in the 21st century will be the automatic machine, the automatic robot. I'm writing an article right now for Forbes magazine about how automation is coming for white-collar jobs too, in healthcare, in law, in accounting. They're using bots to do a lot of the repetitive work that accountants, that healthcare professionals, and lawyers used to do. So we know about how automation is displacing blue-collar workers, whether people driving cars or whether people working in warehouses. But now automation is going to displace or disrupt a lot of aspects of our life. For example, this is my little friend. This is a humanoid. A humanoid is a robot that tries to act like a human. This is Alpha. Alpha was created by UB Tech Robotics, one of the largest robotic builders in America, and STEM Nola's partner. Alpha can do all type of physical activities just like you. Alpha can do push-ups. Alpha can show off just like you. Like when I get off my Peloton, Alpha take her time getting up. And if you think you're gonna go out there and compete with Beyonce and you're gonna be the next great entertainer like Michael Jackson, who's that little boy in Las Vegas right now? I can't think of his name. Dub Baby and Love Baby and Your Baby Baby. If you're gonna be all them, guess what? You're gonna have competition in the 21st century. Get it, Alpha? Alpha has servo motors, and through Bluetooth technology, we can use our telephones and code and control Alpha. And Alpha does what we tell Alpha to do. Alpha can gig. Can you imagine a series of robots marching into the stadium during halftime and doing the thing? Do it, Alpha. This is your competition in the 21st century, especially if you're training yourself from the neck down. All right, Alpha, you're doing it. I'm getting tired of you. Give it up for Alpha. That's your competition. And they're building life-size robots now to compete with you. Elon Musk announced at the beginning of this week that he will begin working on humanoids that can do basic human tasks. Tech Robotics is building a robot called Walker. Google it. And Walker, they say, is about 10 years off, but the real mechanical things that a human does, Walker can do. Is those soft things, right, that we do that robots have not been able to conquer. So when we train our head, we also have to train our heart, because when we train our head and our heart and train ourselves from the neck up, we can control the robots so that the robots will not be able to control us. That is our why. That's why we do what we do. So you can become STEM literate and have a basic foundation to go forth and make all your dreams come true. That's why we're here. And today we'll be studying the heart. You're going to do all different activities on the heart and on circulation. And we are very excited about it. Now, from the University of Illinois, I want to bring up my friend, Dr. Ruby McKindendahl. I messed it up, Ruby. I'm sorry. To bring greetings on behalf of the University of Illinois.
Thank you, Dr. Mackey. Love the robot, love the movement. So welcome everyone to the live session of STEM Illinois at Home. We are super excited that we are able to benefit from the gift and truly genius of Dr. Mackey and his vision, right? His vision is from coast to coast, and we are welcome. We are happy to be a part of that. And then also STEM Illinois is creating this ecosystem, an intergenerational one. So hopefully your parents are watching with you as well. We say the mother, uncle, sister, brother, cousin, because we believe it takes the whole village for young people to succeed in STEM. And then also at the College of Medicine. So today we're learning about the heart. And if you feel like medicine or biology is your gift, is your passion, you spend hours doing it, or even if you're curious about it, definitely listen, you'll learn. And then also to let you know that we have a pathway program to medicine. So if you're interested in that, we have programs that can hopefully have your young people here at the College of Medicine or other colleges of medicine or in biology. So again, welcome, welcome, welcome.
Thank you, Ruby. Thank you, Ruby. And I want to say hello to all the kids in Champaign and Urbana. I want to say hey to my friends in Peoria that's on. I definitely want to say hello to the young people in Aurora, Naperville, Rockford, and Chicago. People have been texting me like we're getting on this week. Ruby and Will, we're making this thing happen. Before it's over, you all going to be engaging the entire state. Thank you all for that opportunity. Thank you for that welcome. Young people, we believe that what we built is a model for community in STEM. We believe that model is child-centered, adult-governed, elder rule, meaning that we focus on the young people, the K-12 scholars. We surround them with college students. Later on, you would have one of our college interns present the lesson to you. Then we surround those college students and K-12 students with STEM professionals like myself, like Ruby. And next up, we want to bring up Lidija Barbaric, who's a fourth-year medical student at Illinois College of Medicine, to talk to you about hearts. We want you to see people at every stage in life to let you know that you can do this too. Lydia.
Hi, thank you so much. It's nice to meet you all. My name is Lydia. I'm originally from Pittsburgh, and I am a fourth year at the Illinois College of Medicine. It's so nice to meet you all today. I'm going to hopefully be explaining a little bit about hearts, and I'm sure you all know a little bit about what hearts do and what they can do. And if you have any questions, just feel free to reach out to me. Any of you kids interested in either science or medicine, I did a lot of research before I got to medicine. And I started when I was probably around your guys' age, doing science projects and looking at bone mechanics is kind of where I started. And then I looked at tissue engineering, so creating new bone cells out of stem cells. So that's a topic for a different day. So I'm gonna share my screen here with you guys. Hopefully you can see, and anybody please let me know if you can't. Yeah. Oh yeah, I'm sharing. Okay, great. So I'll share with you guys some nice pictures from the internet I found of the heart. So I just want you guys to think a little bit about what the heart does in your minds. I'm sure you all, the first thing you think of is it pumps blood, right? What if I told you that blood is actually not made in the heart? It's actually made in the bone marrow, in our bones. So I'm sure some of you, if any of you are meat lovers like I am, maybe you go to a restaurant and have some chicken or something, or maybe a steak, and you ever cut it open down the bone and see like a purplish mush inside the bone, that's bone marrow. And blood and the products of blood are actually made in the bone, but then they combine with the circulatory system to actually create the blood that's going to then pump through what we call the cardiovascular system. So this is an anatomical picture of the heart. And if you take a look at your hand right now and look at the little blue veins in your hand, those are one type of vessel in your circulatory system. And then you have arteries. And now the blue veins in your hand, that's carrying what we call blood without oxygen, deoxygenated blood that's going to come back to your heart through one of these large vessels. I don't know if you guys can see my mouse. Please let me know if you can or if you cannot. But so it's going to be delivered back to the heart, go through this 4-chamber system, then go to the lungs to pick up oxygen, come back to the heart, and now that it's oxygenated again, go to the rest of the system. So my answer to what the heart does is it delivers oxygen. Now, another thing maybe cool to think about for you guys is just ask yourselves what's important. What's more important, the heart or the brain? Now, I would never ask you to choose between those two. You need both, of course. And some of you might think, as I used to, that the brain controls every little thing in the body, right? The brain is how we function, right? It's our we call it the central nervous system. But what if I told you that the heart can pump without the brain? What if I told you that the brain actually depends on that oxygen delivery from your heart? So if you take a wild guess as to how long the brain can last, the brain cells without oxygen, it's actually 4 minutes. The brain cannot survive more than 4 minutes without some oxygen going through it. So I can tell you guys a lot of things. Well, let's start with these 4 chambers. So we have 2 atrium on top, 2 ventricles on the bottom. And then we have these special valves that prevent backflow and keep the correct flow of the blood pumping through the heart to go to the lungs and then come back into our left atrium, go through our left ventricle, and then shoot out to the aorta to reach the rest of the body. So here's another graphic view. I like this one because it shows these valves. These are atrioventricular valves, and I think they look like little parachutes. I think it's so interesting how they look. And they have these special muscles that pull them up and down as the heart is pumping. And now here's a lovely animation of what I was just talking about. Blood's going to come back to the right side, go to the lungs, come back to the left side, and then back out into the rest of our system. So again, this interesting brain-heart connection. What if I told you that the heart cells are actually like the neurons of the brain? The heart makes its own electricity. And the heart is a muscle that needs oxygen too. So on top of the heart, you actually have vessels that get blood from the heart. The heart kind of feeds itself in a sense. And so it creates its own electricity. And as long as it has that blood and that oxygen, it can keep pumping. This is a transplant patient who's receiving a heart, and the heart is outside of the body. This is someone else's heart that's going to be given to this patient. And you can see these tubes around it, providing this constant circulation of oxygen. And this heart will pump on its own. So if the heart makes its own electricity, where does that start? It starts in the right atrium, in a little group of cells that sit in this pocket on the left side of my screen in the right atrium. There's this group of cells known as pacemaker cells, and they send an electrical signal to the muscle cells of the heart. So I want you guys to just basically think of the heart as having two types of workers. You have the pacemakers and the muscle fibers. And the pacemakers are going to tell the muscle fibers how to pump and what rate to pump. So I'm talking about biology so far, right? Now I'm talking about electricity. That sounds like physics. So I'm sure you guys have been to either Disney World or a carnival. You buy tickets, gates open, and you ride the rides like the roller coaster. The roller coaster is my favorite. The heart is kind of like that. There are little gates that sit on those pacemaker cells of your heart. And when a certain amount of ions, sodium and potassium, which are electrical charges, when they build up on either side of those cells, a spark happens and that roller coaster goes up and down. So the spark is what sends the signal to the muscle cells. And then once the muscle cells get that signal, a flush of calcium comes in and it acts like a fuel that sends signals to those other guys I talked about, the muscle cells, to actually pump. So isn't that cool? You can study chemistry, physics, and biology if you're studying the body. So just to wrap up, because there's so much that I could tell you guys about the heart. And if you have any questions, just reach out. But what I think is really cool about those pacemaker cells, they're like, to me, the drum major of your heart. I don't know if you guys are in band. When I was in your age, I was in marching band. I loved it. And we had to look up and listen to the drum major and keep our beat. And so that's what the pacemaker cells are. And sometimes the drum major is off. It stops working. And in the heart, we actually have other little groups of pacemaker cells, little buddies linked up, ready to go to take over when the main drum major stops working. But the bad thing is that they tell the heart to pump at a slightly slower rate. But hey, they're taking over for the time being until a surgeon and doctors and other people come along to maybe implant a mechanical, man-made pacemaker into the heart. I'm sure some of you have family members that have a pacemaker, and that's what that's doing. It's taking over the job. So that's a little introduction for you guys. I'm going to hand it back over. Dr. Mackey.
Thank you, Lydia. Thank you for that great explanation of the heart. If that's something that's online, you know, because I was like that. I'm like, we need that. Why we don't have PowerPoints that move like that? I'm looking at everybody in the room like, y'all better get to work. Somebody better call Lydia and get that PowerPoint. But thank you, Lydia. Congratulations and continue, you know, best wishes to you with your studies. Dr. Ruby Mendenhall, thank you. And Will Patterson, everybody from University of Illinois, thank you. Now we're gonna bring up one of our college interns. And just to let you know how this is gonna work, when we start doing this, we're training the people in Illinois. When we start doing this, all of this will be alumni and graduate students from the University of Illinois, and it'll be college interns from your community. So this will be owned by your community, and we're very happy about that. But next up is DeMarco Smith. DeMarco Smith been working with STEM Nola approximately 3 years. He's working on his chemistry degree at the university, at Xavier University of Louisiana. And he's in a dual degree program where you go to one school for 3 years, then go to another one for 2. He's going to be going to LSU where he's going to get his chemical engineering degree. And I'm very excited about that because that's what I did as an undergrad. I went to Morehouse and got a degree in mathematics, and I left Morehouse and went over to Georgia Tech, where I got another BS in mechanical, then a MS and PhD in mechanical engineering. So it's good every time DeMarco is here. He's doing well in school, and we're excited for him. And I'm going to bring DeMarco up. And I want to say thank you to everybody. I have to run out, so I won't be back at the end. But believe me, you're in good hands with DeMarco. DeMarco.
Hey guys, you guys ready for today? So as he said, as Dr. Mackey said, my name is DeMarco Smith. So first things first, before we get started, I'm going to do a cool, awesome heart dissection. Are you guys ready? So before we start, always safety first. So we're going to get some gloves. So now that I have gloves on, finally, guys. Next thing's next. We're gonna take our sheep heart out. Now keep in mind, guys, it smells really, really, really bad.
Don't say that.
Check it out. Cool, right? So as you guys can see right here, where they have like little holes, you guys see? This is called the aorta. It sends blood all across your body. And then, let's see if I can find a little tube. The artery, we have a tube called the artery. It's right here. It's kind of smushed together. That sends blood to your lungs, okay, guys? Then we have the right atrium and the left atrium. And then we have the left ventricle and the right ventricle. Check it out. So our next step, I'm going to take our scalpel and open it up. And I'm going to make an incision. Let's see. Check it out, guys. So as you guys can see, as what our medical student was telling us about, the insides, how we have muscles in the inside, which contracts blood all around the heart. So remember, guys, our heart is a muscle. So if you guys ball your fist up right now, so ball up your fist. Ball it up. So this is the size of your heart, guys. So whatever size is your fist, that's the size of your heart. Pretty cool, right? So let's see. So next I'm going to cut open. I'm gonna cut it all the way open, okay, guys? So in some parts of our heart, our ventricles can be a little bigger than others. So with that being said, check it out. You see how this side is thick and this side is thinner? That means our heart pumps more blood on this side. So think about it like this. When we work out, right? And when we lift weights. So say for instance, we lift 10 pounds versus 40 pounds. If we're lifting 40 pounds every day, it's gonna make us, we can be able to gain more muscle by lifting 40 pounds than 10 pounds. So that's that with the heart dissection. So you guys ready to move on to the experiments and for the rest of the day, guys? Yeah. Awesome, awesome, awesome. So first things first, let me clean this up, guys. So for the agenda today, we're gonna do topic introduction, vocabulary terms, activity introduction, objectives, activity questions. Activities for today is mechanical heart. And then we're gonna have activity questions and answers. So you guys ready for today? Great. So as you can see, our first vocabulary term is the atrium. It's a thin wall chamber that receives blood from the veins. Remember, guys, it's a thin wall chamber that receives blood from the veins. Next vocabulary term, ventricles. It's a thick wall chamber that forcefully pumps blood out of the heart. So you guys remember what I told you about? Say, for instance, one side can be bigger than the other. So think about it, again, lifting weights. If you lift more weights, you're going to get more muscles. If you lift less weights, you're going to have less muscles. So remember, guys, heart, the next vocabulary term is heart. Heart is I mess this up all the time. Hold on, guys. A heart is a muscular organ in most animals which pumps blood through the blood vessels of the circulatory system. Our next vocabulary term is circulatory system. The system that circulates blood and lymph through the body, consisting of heart, blood vessels, blood lymphs, and lymphatical vessels and glands. Next slide, please. So we have the objectives for today, guys. Are you guys ready? So before I do the objectives, I'm going to talk about the parts of the heart. So remember I told you guys about the aorta that pumps the blood all around your body. You have the left atrium. You also have a right atrium. You have a left ventricle, and also you have a right ventricle. So the objectives for today. You will understand the meaning of the term blood vessels, heart, and circulatory system, and apply them to the project correctly. You will examine a human body heart, body, and circulatory system, and learn how to build mechanical heart. Next slide, please. So what are we experiencing with today, guys? Is it rockets? Is it hearts? Is it buoyancy and density? You guys got it right. It's hearts. Awesome, 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 guys. I see you guys paying attention. Okay. So, questions of the day. What does the middle of the bottle represent? Next question. What pushes from the atrium into the ventricles on each side of the heart? Last but not least, what is the circulatory system? So we're gonna get into our heart pump. So get your supplies out, guys. First things first, you're gonna need water bottles or even a soda can with caps on them. You're gonna need 3 cups of water. You're gonna need 4 bendy straws, tape, food coloring, and clay and Play-Doh. So as you guys gonna get these materials, I'm gonna read the science behind it. In our heart, we have 4 chambers, the right and the left atrium, the right and left ventricles. Blood can flow in one direction only, into the heart, into the lungs to oxygenate, back into the heart, and back into the body again. Our hearts have 4 valves, are critical for maintaining blood flow this one way. In our heart model, the first bottle full of water is the atrium. Remember, The first bottle is full of water in the atrium. The middle bottle, guys, remember the middle bottle, this is one of our questions, so keep in mind, the middle bottle is a ventricle. And the last bottle, which is empty, is either the lungs or the body. Also, our finger represents the valves of the heart. So you guys ready? Great. So first things first, we're gonna need 3 bottles, guys. Remember, 3 bottles. And remember, they all have to have bottle caps on them. So you're gonna need 1 with 2 holes, 1 with 1 hole, and 1 with none. It's gonna look just like this. Great, great, great. So first things first, we're gonna need some straws as well. So grab some straws, at least 4. I bought extra just in case. So we're gonna need 4. Also gonna need clay. Okay, and we're also gonna need tape. So just to keep in mind, guys, if you guys don't have holes in your bottle top yet, just take your time, create holes and things like that. So while you guys doing that, I'm gonna be opening the straws, okay, guys? Yeah. Hold on, let me see. Okay, guys, so I have 4 straws. Make sure they're 4 bendy straws now, guys. Bendy, this is the major part now, guys. So remember, now next step, we're going to put the bottle with 2 holes in it and 2 holes in the cap in the middle. And we're gonna put this one on the right-hand side with 1 hole on the right-hand side and on the left-hand side, guys, the left-hand side. And then the right-hand side is gonna be the bottle with no cap on it. So our next step, we're gonna put the straw inside of each other. So the best way to do this, I find, is to kind of pinch it a little bit together and push it inside. Just like that. You guys see? And once it's pushed inside, you're gonna grab tape and tape it up. So I'm gonna use clear tape. And when you use clear tape, just wrap it, seal it as nice and tight as possible. Make sure we have no air leaks. And I'm gonna put 1 more piece of tape to make sure it's extra secure. So once that's finished, guys, make sure you extend your bendy straw, extend, and you guys can put 1 side of it in. And put it the other side into the other bottle, just like this. Next, you're gonna do the same thing, repeat it. So we're gonna pinch our straw just a little bit to push inside. Perfect. Remember to extend, guys. Next, you're gonna get tape and we're gonna seal it up again. We don't want no leaks. Okay. We're gonna add extra tape just to secure it. So, as you guys see, the first step we did was put our bottles in line order. Put them in a line, guys. So the middle one should be the one with 2 holes in it, okay? 2 holes in the bottle cap. The one to the left is gonna have 1 hole in the bottle cap. And then the one all the way down here to the right is gonna have no bottle cap, guys. Then the next step we did was get 2 straws. Remember, it have to be bendy straws, guys, bendy straws. And we kind of pinch them to push it into the side and push it inside the straws. So remember, guys, it might be a little difficult to push the straw inside another straw. So just remember to pinch it and push it through. Then after that, we use tape to seal it up. I did double sealing just to make sure we don't have no leaks. Absolutely no leaks. And remember, guys, we have to do 2 sets of them. 2 sets. We push the straw inside the other straw. The best way, again, to pinch the straws, guys. Pinch the straw and then add tape around it. After that, we're going to put it inside the bottle. So it should look just like this, guys. Next things next. We're going to need some water. So now that you guys see how it's going to look, we're going to add water inside the middle bottle, the one with the 2 holes in it. And then we're going to add water inside the one with 1 of the holes in it. Okay, guys? So we can take this out, our straws. And we're going to take the caps off it. And we're going to add water inside the middle one and the one to the left. So that's the middle one filled up. And now we're doing the left one, guys. It doesn't really matter how much water you put in it, but I like to make the middle one more than the left one, guys. So remember, the middle one more than the left one. So check it out. Now, guys, remember, the water represents the blood. So in order for our water to look pretty cool, get some red food coloring. So let's see. We have blue. And the red one should be right around here. Okay, guys, I don't really see the red, but I'm going to use blue instead, okay? So remember, the blue is represented as red food coloring. So I like to put a lot of drops in the middle one, just so when we use the ventricle, because remember, guys, this represents the ventricle. So when we squeeze this, water goes from both to both ends. Basically, it's pushing blood to both bottles. It goes all over the place. So when I like to do that, I like to see the blue come up, go over to the left side, and drop blue into the clear water. So that way you can see how blood can be able to function around your whole body and goes around your whole heart. So let's check it out. We're going to put the one with 2 holes back on top. Then remember the bottle cap with 1 hole on the left side, the one that has water inside. You can either make this the food coloring dye that you're using to create blood. You can already put it there, but I'm just leaving it clear for now because when the blood comes up out the ventricle, it's going to go over to the left and it's going to create blue. And I think that's pretty cool to see how blood moves over and creates more and more. It just pumps all over the place, guys. So now that we finished that, grab your straws we made. Remember the set of straws we combined it? Insert it, insert it. Great, great. Now our last straw. So guys, do you guys think that's it? Let's see. You guys can hear a little air coming out. If you guys can hear the little air coming out, that means we have an air seal leak. So remember our last ingredient? Clay. We're gonna use the clay to cover up all the air seal holes that's around the straw, guys. So you guys can use regular clay dough, molding clay, any type of clay you want to. So let's see. So secure it really well, guys. You don't want to hear no air. And remember, guys, we're going to do the middle, and then we're going to do the one with the one hole, okay? The one hole in the bottle cap. So make sure you pinch it on real nice and try to smooth it out to secure it on, guys. So let's see, let's see. Now let's check it out. You guys see how the blood is moving? So with my diagram, I still have a little bit of air coming out. So let's see. So remember, guys, science experiments is about trial and error. So if you're experiencing anything like this, just go back and fix it, guys. We all scientists at the end of the day. So let's try to secure it try to get it as secure as possible. We don't want no air holes coming out because we don't want no leaks. Absolutely no leaks. Because I don't want you guys to create a mess, and I don't want to create a mess. So check it out, guys. Let's see. You guys see it? You guys see how the blood is moving from the middle to both sides? It's going to the left, it's going to the right. And as you can see, guys, you see how the blood goes all over? It's even turning that clear blue. I just wanted you guys to see how our blood travels up and goes to the left. It goes all around. It goes all around the heart, as you can see. And you guys see how you have some blood that come out over here? Check it out. So guys, that's it for the experiment for today. So do we have any questions so far? Any questions? Okay, guys, remember the questions of the day. What does the middle bottle represent? Is it the ventricle, is it the blood, or is it the atrium? Remember, guys, the middle bottle. That's correct. It's the ventricle, guys. Great, great. Awesome, awesome. Next question. What pushes from the atrium into the ventricle on each side of the heart? Is it water, blood, or juice? Water, blood, or juice? That's correct, guys. You guys are super smart. It's blood. Awesome, awesome. Last but not least, what is the circulatory system, guys? What's the circulatory system? The system that controls your entire body? Is it a system? That's correct. It's the system that circulates blood through the body. And of course, it's not the other one. Well, guys, you guys did great today. Any questions for me? If there's no questions, you guys can email us pictures. Please, please email us pictures. We are so excited to see you guys, which are fun experiments, cool experiments. So email us at webinar@stemnola.com. And remember, guys, we're going to be here Tuesday, August 31st, 2021 at 4 p.m. And the next event is going to be based on sound, guys. So see you then.